So 1.7 as a whole is going to be looking at two things, midpoint and distance. But we're just going to focus on the first of those in this video, and that's going to be midpoint, specifically in the coordinate plane. We're given two formulas for midpoint at the top of the page, and that's going to be either on a number line or a coordinate plane. Again, two different situations that we may maybe beginning with. And in the first case, again, if I'm just looking at a number line, that's going to be the coordinate midpoint is considered the average, or again, mean is another way of saying average, of the coordinates of the endpoint. So if I'm given an endpoint for A, endpoint of B, and I'm looking for the midpoint of a segment from A to B, I can average those together. And as we do with any other average, we're going to find that by adding up those two coordinates, dividing by 2, because that's two coordinates we're keeping track of. A little bit more complex if I'm dealing with our two coordinate system, so like your XY plane. We're just going to have to do that twice now that we have two different pairs of coordinates. We're going to find the average of the X coordinates, again, much like it works on a number line, same kind of idea. But we're also going to find the average of the Y coordinates of the endpoints because, again, what we need to do is define that in two dimensions. We need to find basically like your horizontal distance and your vertical distance. We kind of need to average both of those out. That's going to find the midpoint of my segment. Again, notice that the segment's going diagonally. I can go in really any direction that I want and still find the midpoint of that segment going from A to B. We're given kind of what looks like a scary looking formula for the midpoint if I'm using a coordinate system. But if I break it down to its pieces, if I said that the number line is just going to be the average of two coordinates, we kind of do that here as well, except we're just doing that twice. We find the average of your X coordinates. Again, that's going to go in for the X coordinate of your midpoint. And if I find the average of my Y coordinates, just going to go in for the Y coordinates. So we're just doing the same thing, just doing it twice now that we have X and Y. Trying that with a couple of examples, we have AB with endpoints at -4 and 9. Again, this is our first case. We're just finding this along a number line. So if I'm looking for the coordinate of the midpoint of AB, all I got to do is I just have to take the average of those two coordinates. Again, that's just where is A located, where is B located on my number line. I want to just add those together, divide by 2, because that's how I'm going to find that average. B looks like it's at 9 rather than 8, sorry, and that looks like it's given to us up above as well. But as long as I add those together, again, -4 plus 9, I get 5. 5 over 2 is enough. Again, we don't really have to translate this to a decimal or anything. If I'd looked at 2.5 or like 2.5 on my number line, it does look like that's where the coordinate of the midpoint would go if I'm just kind of estimating anyway. But again, just on a number line, add the coordinates, divide by 2. We're essentially just finding an average there, so averaging those, we get 5 over 2. If I'm instead using a coordinate plane, again, notice that we don't actually have the coordinate plane drawn. Instead, we're just kind of describing this as a segment. So EF as a segment from E to F with those two endpoints given. We want to use that to find the coordinates of the midpoint. So I think what's going to be helpful, and notice I've actually kind of did this in the question that comes later, is what I always like to do in this kind of situation, just label. Again, if I have two pairs of coordinates, it's good to keep track of what's my first coordinate pair and what's my second coordinate pair. Actually, it doesn't even matter which we consider the first and which we consider the second. I could just as easily have used like E for my second coordinate and F for my first coordinate, and that's still going to give us a correct answer. But if we go back to that formula from the top, what we're going to have to find is, again, the average of the X coordinates. That's going to be my first coordinate for my answer. And again, if I find the average of the Y coordinates using that same kind of method, I can find the Y coordinate of my answer. So just substituting in the values that we have from E and F. Again, we chose E to be the first and F to be the second, although here it's not too important. As long as I can just add the X's together, divide by 2, averaging out the X's. If I add the Y's together and divide by 2, being careful that we're adding a negative, that's going to find the average of your Y's. And if I simplify those, I just get 9 over 2, and it looks like 1 over 2. And even though we're using fractions, that could work out for the midpoint of a segment because, again, it could just really be anywhere on that coordinate system. So the only difference, again, between these two methods is on a number line, you're just going to have to find the average once. On the coordinate system, we have to find that average twice because we need to do it with both the X and the Y coordinates. Good to try these next two together, and again, it should just be like A and B from up above. We have a number line question and an coordinate system question. So if I'm finding that on a number line, again, it's as simple as just adding those two coordinates together and dividing by 2, finding the average of those two. Comes out to -4 if you did that one correctly. And again, I kind of labeled this one already with x1, y1, x2, y2. We just chose those to be our two coordinates. But if I find the average of the x's, I get 4. If I find the average of the y's, I get -2. We essentially do the same thing we did with the number line, but we just do it twice because we have x coordinates and y coordinates. So if I know the midpoint and the endpoint, we can actually use the midpoint formula to find the other endpoint. So again, this is a case if I'm trying to picture what this looks like. We know the midpoint of CD, so I'm just going to draw this CD as a segment off to the side. Not going to exactly be in the correct location, because notice that we should be kind of going at a diagonal if I'm drawing this in the coordinate system. I'm going to keep that simple and just draw that like a horizontal line. But if I had the midpoint of the segment, and if we know in this case where the midpoint is, on our last question, we knew what the coordinates of the two endpoints were, and we're just trying to use the formula directly to find that midpoint. Here, we're actually going to work using a different starting point. Here we know that the coordinates of the C is given, but D is not, but we're going to have to use M as a midpoint in order to find that. So the reason why we can still use that same formula, I'm going to write that formula up above. Again, we just average the x's, and that's going to be my x coordinate. If I average the y's, that's going to be the y coordinate of my midpoint, is because we still have enough to work from. We have essentially, again, the midpoint being known. So if I'm trying to find the other x coordinates that's missing, and we're going to have to focus on one at a time, I can use that same formula. If I know the x coordinate of my midpoint is the same as just averaging out those two x's, I know that the x coordinate of the midpoint already is going to be a -2. So if I use that same formula, I can substitute -2. That would be the answer for my midpoint. We know one of the endpoints is at, again, given -5 for the x coordinate. We just want to figure out the other one, so that's the one that's unknown. This is the part that would be over here for D. That's one we're trying to figure out. So if I just average those together, again, normally I would just be able to add those and divide by 2, but here I just have to solve algebraically. We know what the average is. The average of these two should be -2. We know what one of the pieces is, -5. We just have to use that formula to find the other missing part. So solving this algebraically, I'd multiply both sides by 2. I want to get rid of that fraction. I can add 5 to both sides, so I get 1 as my answer for x. And there's also a different way I teach this too. If I know that the x coordinate, remember, was at -5 for one of my endpoints, and if I know the midpoint, again, the midpoint x coordinate was at -2. Another way to get there is also by thinking, if I go from -5 to -2, I have to get there by adding 3. And since that's a midpoint, I can also find the other endpoint just by repeating that same process. It should be halfway anyway. So if I took -2 and I added 3, that's another way to get that your answer is 1, just like we already found. But again, we've only answered for the x coordinate. We also have to answer for the y coordinate. So if I add that part in as well, we can use the same type of formula. Not the same exact formula, because now we're just using y's instead of x's, but same reasoning as before. We know the coordinate of the midpoint should be 1 for the y value, so if I know the midpoint already, I can kind of go backwards and find out one of those two missing endpoints. We're given one of the endpoints had a y value of 7, so if I start with 7 and try to find the one that's missing, I'm just going to call it y for now, although you could also just kind of use y2 in that formula. Same as what we did for the x's, I can just take this and solve that for y. Multiplying by 2, I get 2 equals 7 plus y. Subtracting 7 from both sides, I get that my y coordinate should be at -5. And that actually completes our answer, because now we have both. We have the x coordinate and the y coordinate. We know that the x coordinate was at 1, the y coordinate was at -5. And also, if I repeat that same process, remember there's a different way to kind of count over and use that same kind of reasoning. If we know the y coordinate was at 7 for one of my endpoints, and we know that the midpoint was at 1, same kind of thing we did with the x's, we can just kind of repeat that halfway type of process, and that's going to tell us where our y value is going to end up. We should know the answer already because we used the formula, but if I try it this way, again, I have to start with 7 and subtract 6 if I want to get to that midpoint, so take away 6 from my y's, and if I repeat that again, if I take away 6 more, again, 1 minus 6 is also a way that we got that same answer. -5 is my y coordinate. So really you can kind of choose whatever method you're most comfortable with. You can stick with the formula that's itself and just know that we know the left-hand side. We know x is -2 because, again, the midpoint is given to us, and we can work our way backwards to figure out what was missing. Or I do see a lot of people that do prefer this method. If I know that -5 is an endpoint and I know I have to get to -2 to get halfway, I can repeat that process and add 3 again, and that's going to get me to the other side, so that's going to get me the other endpoint. That works with the x's, and it also works with the y's. So again, really just your choice on what you understand a little bit more in terms of finding the other side. As long as we start with, one endpoint given, that should be enough to find the other endpoint. So try it again. Again, this is probably the toughest question from finding midpoint, but see if you guys can try that with the next information. Again, kind of like the previous question. You start with one endpoint, and you also start with a midpoint. Trying to look over that answer now. And again, there are 2 methods that I kind of listed here that you guys can use to solve it. The first, again, is just to use your midpoint formula. And I just use like xm here to abbreviate like the midpoint of my x coordinates. Again, we already know that. Like we already know the midpoint of my x's should be at 4. So if I know that one of my endpoints is at -3, really all you're finding is, again, essentially this second coordinate, That's the one that we don't know yet if I'm looking for like coordinate for B. So working through my formula, again, 4 is going to be the average of those two, one of them being missing, but I can still solve that algebraically and find out that the missing coordinate was 11 for X. I can also work through that question and figure out the same kind of reasoning for Y. Again, same formula, as I know that the average of the Y coordinates is going to give me the coordinate of the midpoint, which we know is already -9. So if I work my way algebraically, again, I can also get a solution for Y on that. Or again, if you do prefer the counting method, it works the same way as before, where I can see if -3 is one endpoint and if 4 is given to me as the X coordinate of the midpoint, I know that to get from -3 to 4, again, to get basically halfway across my segment, I would have to do that by adding 7. So again, -3 plus 7 is going to take us to 4. And then if I repeat that same process, again, if I know that I'm at the midpoint, 4 plus 7 more, that takes me to the other side. So again, that's going to be the coordinate of my answer for the X. If I do the same thing with the Y's, again, works out pretty much the same way. I know the endpoint, I know the midpoint. I just need to know basically how to continue that process to get to the other half. So if I start at -5 and I want to get to -9, I do that by subtracting 4. And if I repeat that again to get to the other half of my segment, -9 minus 4 more, that does bring me to -13. So again, really two ways of getting that same answer is just to either use the formula that we're given and solve algebraically, or you can kind of use that halfway counting method, and that's another way to also get you both the X and the Y coordinates of the midpoint just by adding or subtracting to get halfway.